We are live. Oh, very good, very good. Très bien, très bien.
Bonjour,
Bonjour.
bonjour. Welcome everyone to another episode of AI Biostats etc. And today we will have a special guest, actually a digital replicant. Um, did anyone see Bruno on the show? Where's Bruno?
No, this is Yann Lequin here. Bruno will not come today.
Oh, so Bruno is not coming.
No,
So
no.
okay, so we have a very special guest then in the AI world.
Well,
So
yes, yes, I'm very special. Now, I'm the digital twin of Yann Lequin. That's why I have no hair. I look
oh.
like Marc Andreessen. I have no hair, but this is Yann Lequin.
And I noticed that you have the same glasses. Well, that's a replicant of Jan de Kunst's glasses, right?
Yes, yes,
Oh, okay.
yes.
And I assume that you can tell us, Mr. Lacoon, that I assume that you really like large language models. You always say
No,
good things about them.
no. Uh, Not at all. Actually, I think that they're useful. Okay, they're useful, but they're smart. They're not as smart as your cat. Your cat can learn in very quickly how to catch a mice. A kid can learn in no time how to drive a car. These LLMs cannot learn that. They don't have a representation of the world. They just guess the next token. They don't know what they're talking about. And I said that for a long time. They're not going to get to AGI or to ASI. This is just not going to happen, right? I've been on the record for a long time to say that. It's not going to happen. Forget it. Forget it.
Well, sir, I must agree with you. I've been saying that also for a while. The people have been saying like, "Oh, AGI is right there behind the corner. It's 2 months away, 3 months away, 5 months away," and they've been saying that for years now. So we are actually seeing that large language models are just not getting us even close to AGI. And a lot of it has to do with the tokens and stochastic parrots. So maybe you would like to tell us a bit more about that. What do you think about stochastic parrots, Mister?
Yeah. You said token. I like the Lord of the Ring GR token, for example. That's a kind of token I really like. And yeah, guessing the next token is not going to get us to AGI for sure. This is why I decided to leave Meta and to start AMI. AMI. Now, AMI in French means ami. Ami
Ami.
means friend. It means friend.
Oh,
Ami.
oh,
Yes, because we are the ami of the investors. That's why they gave us $1 billion. And the biggest seed round ever, certainly for a French company, right? And so we're going to. And I tell everybody, if you're young today, like me, you don't want to invest. You don't want to spend your career in LLM anymore. It's over. There's nothing new to do. These big companies are spending trillions of dollars in it. So if you want to innovate, if you're new to AI, if you're young, you don't want to do LLM, right? It's a career mistake. What you want to do is something else, right? New algorithm, new approach, and of course, as you know, for me, it's models of word models, word understanding. Um, that's really where the action is to understand the reality behind the modeling or the mimicking of intelligence that LLM has generated. It's actually here's a reality, all right? LLM are actually not that smart. They're very good at sounding smart because language being linear, it's surprisingly easy to stochastically parrot, as you said earlier, right? To predict the next token and to sound smart for language, as opposed to the other representation of the word like videos. Right? Very hard with videos.
yes. And actually, I think that even us humans, we learn so much that visual materials actually just a number of hours, like a few hundred hours of video material, uh, can teach us more than a large language model would learn by burning thousands of GPU power and electricity. So yes, LLMs are quite inefficient, especially that autoregressive self-attention, which I assume, sir, that you're also not a big fan of. And so, what can you tell us about these world models? And I actually read that there is a lot of research that you are doing in this special technology called JEPA. So,
Yes.
what can you tell us
Yes.
about that?
Yes. Yes. Did you say that I had the Turing Award, by the way? Did I mention that?
Oh, I did
No.
not,
Well,
I did not know.
you
Really?
didn't know. You didn't prepare. Well, I'm not blaming you because, frankly, and I speak freely here on your podcast. I should not have gotten a Turing Award. I should have gotten the Nobel Prize and the
Yes,
Field Medal, right?
yes.
And then maybe the Turing Award. My old professor Jeff Hinton got the Nobel Prize together with a Google guy, whatever his name is, Demis. What's his name?
Hassabis.
Hassabis, right? So, frankly, I'm not here to complain, but I should have gotten the Nobel Prize. Also, how about a little field medal for the French guy? The French usually get the field medals, right? So I didn't get the field medal either, but I got the Turing. I got the Turing Award, so I guess that's okay.
I
I
mean,
guess that's okay.
maybe we should nominate you for the next Nobel Prize right here
For
on the
peace,
podcast
for
for peace.
right, for peace, right?
I mean, you definitely deserve. Yes, I mean, Demis Hassabis is a smart guy. Geoffrey Hinton as well. But I mean, Mr. LeCun is like a
Yes,
godfather of convolutional neural networks. You know, when people
yes,
were actually, I don't know, playing simple 2D video games, Mr. LeCun actually
yes, yes.
predicted
I'm from
digits
Brittany, by the way.
from
I'm from
Brittany.
Brittany.
Oh,
Yeah,
yes.
Jan, kind of from Brittany, and yeah, I like convolution. You know what they say about French people? Why make it simple when you can make it complicated? That's the key. So with a little bit of convolution, and especially anything recursive, can be recursive, and then you back propagate, and you side propagate, and you downgrade, you gradient descent, and you gradient propagate up. That's when we know you
Yes.
get something. That's when we know we get something.
I really like that. You know, I think that we should all solve problems like that
No,
because
no.
yeah,
Yes, because the word is complicated, Darko. The word. So why would AI be simple?
yes, it's
The word model, the word. Look.
nothing is
There's a
simple.
tree. There's a tree behind me in the cafe. What is going on? The word is complicated.
Why would we like simple? I mean, everybody likes simple. Why? Why?
What's
Because
for
as you
simple?
said,
Yeah,
simple is just not what we want, and
it's overrated. It's overrated.
it's so overrated. People just feel in the comfort zone. So hey, this is simple. Let's simplify this. But actually, a lot of things are just complicated. Why not embrace the fact that everything around us is complicated, especially the world models, right? The world
The word
models.
models.
Yes.
Exactly. We want it complicated. And that's what
Yes.
JIPA it comes in.
Oh. Oh. So
JIPA, yeah.
so what's so big, and huge about JAPA?
Well, get me started. So JIPA, joint embedded propagation. Uh, what is the
Yes. The
Yes, JIPA,
JAPA.
JIPA. I like the way it sounds. I like the way it sounds. Seriously, well, let's stop kidding for a second, all right? Because this is serious. French people also are serious. Yeah, we like complexity sometimes, but we 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 essentially are very serious people. So um, AI has been around forever. It's been around for 60 years probably, and forever it was the technology of the future that continued to be the technology of the future every year. It was always a technology of the future, and for a long time, word model, uh, semantics, rule-based representation were the name of the game. We tried forever to have complex semantic representation of the word, and by and large, it did not work. It didn't work. Now, of course, then machine learning arrived, and there was some great success with the first wave of AI that powered social media. And then, of course, the biggest break was then with LLM, and nobody saw it coming. So, uh, the work that I did, the work that then the people at Google did, all of that led to so the so uh, uh, um, attention is all you need, of course, and so on, led to the LLM wave, and nobody expected the incredible success that LLM had. And of course, frankly, we don't even understand how they work. We really don't, is the reality. We have some ideas, right? But essentially, brute force next token prediction, when you put $1.4 trillion of compute, okay, on top of all the data on the internet. You take all the data on the internet that we never used to have access to, and now we have access to, with enough compute, then something magic happens. It seems to be very, very, very smart. For a reason we don't fully understand. And that's LLM. And that's incredible. And I guess you could say that's worth the $1.4 trillion and counting. But now we need to do something new, because what else is going to happen? We're running out of data, and there's only so much compute we can throw at it, right? So that's going to be the next step. It's going to be word models, JPA, and EMI. That's us.
Yes, absolutely. And as you said, I'm going to try to be serious a little bit myself, but it's very difficult, I must say, because Yann LeCun is really one of our favorite AI guys, French guys, and we have only best words for Mr. LeCun. And I actually think that Yann LeCun actually deserves much, much more attention, maybe even 10x more attention that is there right now. And the Ami, or as you say, Mon Ami, right? Advanced machine intelligence company, I think, raised around $1 billion, if I'm right. And I think it's not enough. I think Ami actually deserves much more. I mean, if you look at these other companies, like OpenAI, Anthropic, like they're raising like hundreds of billions of dollars. So the technology that is behind advanced machine intelligence, JEPA specifically, which is like one of the most avant-garde, I will use the French term, avant-garde, one of the most avant-garde, yes, one of the most avant-garde approaches where advanced machine intelligence is actually trying to create models that understand the world, not just predict the world, but actually understand the world, turn it into abstraction, and understand how the world works, what's going to happen next. So I think $1 billion for such technology is not that much. I don't know why investors don't actually add more money into AMI. I think they should.
I like the sound of that, and I agree. You're a very wise man, and he's my my pitch to Elon Musk. You might know that I had some difference with Elon Musk on Twitter.
I
I
know.
actually had a
Yes.
few words about him. He had a few words about me. And however, if you want Optimus to understand the world and act on the world, LLM is not going to cut it. You need a representation of the world, a world model. You need the physical understanding. Now, one of the classic example I give is always if you push the glass on the side of the table, the LLM will not know that it's going to fall. I merely did it on purpose to, but pushing like your cat, right? You have a cat that always does that, right? You push,
Yes.
your cat knows that if you push the object on the side, it's going to fall. And it does it with a lot of joy every time. The LLM does not understand that. The LLM, it's not a token. The LLM is not as smart of your cat as your cat. And Elon, and now it's a message to Elon. Again, Elon, we're not going to talk politics anymore, but you're Optimus to fight the Chinese, right? The Chinese have do a lot. You've seen that? You've seen the dancing? You've seen the dancing. Have you seen the dancing that the Chinese are doing? They dance better than Optimus, much better. And so, okay, that's a problem. That's a problem. So if Optimus wants to beat the Chinese dancing robots, if what they call it again, FYB, FBI, or right?
Something
Anyway,
like that.
whatever they call, right? If Tesla wants to beat the Chinese robot, it needs a model of the world. I hereby propose a truth, a political truth between me and you, Elon, and I want to do a deal between Ami and Tesla so that my model of the world can power your robots of the world.
I think we could invite Elon. I'm not sure if he will join us, but why not? He should. He should join us on
Okay,
the next podcast.
please,
Yes, and
please do that. I want peace with
make
Elon.
truth.
Yes, I want a truth.
So
That's right, for Easter.
so so between Mr. LeCun or Bruno Larvol and Elon, who is the truth for?
Well, and exactly. And just to end, it's Easter, right?
Yes.
And when I was a kid, for Easter, what did we do? What did we hide?
Oh, the Easter?
The Easter what?
The Easter egg?
The Easter egg. Look at that.
Oh.
Where's the Easter egg? It's here. The Easter egg.
That's the reasoning. That's the reasoning, I must say. And I was so inspired when you actually mentioned my cat. By the way, if my video goes down, you will know that it's my cat actually hearing Bruno say that, and then she just enjoys destroying everything, destroying the podcasts. So she actually has a world model. That's interesting. My cat, by the way, my cat is called Poppy. It's a beautiful cat, and she actually has a fantastic world model inside her head. And a $1 trillion large language model has no world model.
None.
How cool is that?
Yeah.
How bad is that?
Exactly. Yeah.
I don't know what to say.
That's absolutely right. And now I'm no longer in character. I'm Bruno now. All right. And I want to say, by the way, that I very much enjoy listening to Jan LeCun. That's why I made fun of him, but not really. I just had fun with myself mostly. He has a very convincing style, and I like the way I always learn something from his videos, and it takes a lot of intellectual courage to have an approach completely different, and to say I'm going to do something that essentially has not proven its scales. Actually, has not really proven itself yet. I'm not going to go after the LLM. He could have made $1 billion for himself, probably, by just saying, I'm going to build another LLM. No, I'm actually serious. He could have made $1 billion for himself if he had said, I'm going to build another LLM. He could have built another Anthropic, and absolutely guaranteed. And I think he is so smart, he knew it, and he decided not to do it. Right? So it's really respectful. You have to respect that.
I have a huge respect for Jan LeCun as well. I mean, he was going against the tide, if I may use that term. Like he actually faced a lot of resistance everywhere in the AI community. Like everybody is talking about large language models. Companies are pouring billions of dollars of money into them, and it's pretty much like everybody wants to do the same thing with some variations. Like, you know, we're going to create a little bit better model, but you know, basically everybody is using the same or similar technology. And what Jan is doing, he's saying, no, 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 I don't care what all of you are doing. I'm just going to utilize, even if it's countering everyone, I'm going to utilize the reasoning which I think is correct. And by the way, I have a huge respect for Jan. I don't think anyone should underestimate what he is doing. So I was watching a video of Jan, and I think we actually watched it together, Bruno, of Jan on this old computer. It was like a few decades ago, using neural networks to predict, to actually do image recognition. So like at that time, nobody even knew what AI is. As you said, it exists for a number of decades, but 10 years ago, nobody knew what AI was. And Jan LeCun, much, much before that, was actually using convolutional neural networks to recognize images. So it was crazy to watch that video, and how much time has passed since that video, and how Jan LeCun was actually moving things. These giant leaps that were happening, they were happening because of a small number of people. And Jan LeCun was definitely one of them, and still is, I think. I think the giant leap may actually come from AMI, which is why I'm surprised. And I honestly said that I think that investors should not underestimate AMI. That's my opinion.
The challenge with AMI is that how are you going to spend $1 billion? Because he's doing research. So it's not like scaling your compute on some data. I think it's, I mean, I don't know, maybe unless it's ready to really, I would say, scale up the training of a JPA model. Maybe that's the idea, that if it's still at the research level, there's no way to spend $1 billion though. I could be wrong. Maybe, I mean, maybe he's ready to scale up the training, but I think we will have heard already that his approach has demonstrated success and scalability. So, you know, there's a lot you can do with $1 billion.
Yeah, and I think a lot comes also to the fact that, you know, these other big tech companies in AI, they all have some products that they are kind of, everything in their companies is gravitating around some product. Like OpenAI is gravitating around ChatGPT, Anthropic is gravitating around Claude. So I assume that AMI would need to have a product, which is like their main product, which the whole company will be gravitating around. And that could be maybe one of the ways that they could spend all those millions and potentially billions, hundreds of billions in the future. But I think they're on the right path, right? So they're like, hey, we're not going to rush it. We're not going to just go out and compete with these other companies on a daily basis or a weekly basis. We're going to do it right. Right, we're going to do it right, and when we do it, it's going to be magic. That's how I feel that they are thinking, and I would not be surprised if that happens. As you said, one magical moment was when OpenAI, led by Sam Altman, and huge respect for Sam Altman as well. The magical moment was exactly as you said when you were Mr. LeCun. when they figured out, hey, let's just use entire internet and train this language model, and the some magic will appear. And that principle of emergence is so important. People are underestimating it. Now, I think the next magic will come from another emergence, and this emergence happens when you actually combine all that we have in the LLMs currently with this novel technology that Jan LeCun is proposing. So when you have a large language model which can do all the things that it can do today, just add on top of that advanced machine intelligence that understands the world, that understands the causality of the world. It's very close to AGI. Ironically, Jan is actually often telling people how far away from the AGI we are, but ironically, maybe the technology that he's developing with the team at AMI could be the fastest path towards it. What do you think, Bruno?
Um, well, my problem with AGI or ASI is that it cannot be defined objectively. I mean, I guess the Turing test could be defined, and I think everybody agree we passed the Turing test, right? But I think Christian Cholet or François Cholet has an official or a measurable, falsifiable definition of AGI. But most people who talk about AGI are talking about it so vaguely that it's kind of a little bit silly, I think. So it's more of a marketing concept that captured people's imagination, which is great, but not really a measurable and frankly continuous. There's no, here's a problem with AGI. Either you define it vaguely for marketing purpose, okay, and that's fine, or you define it objectively, but now it is essentially a continuous. There's no inflection point. There's no inflection. There's no step function. It's a continuous progression, and so it becomes artificial. What you call AGI, because it's a spectrum. It's like autism. That's it. There's the AGI spectrum. Eventually, there's no clear-cut, non-arbitrary definition of AGI. So that's what I would say. But okay, what does the M of AMI means and the A of JEPA?
Yeah, I think for JEPA, it's A is architecture, and for AMI is a advanced machine intelligence.
Okay, I understand. And now here's something I don't understand. I'm not a scientist, by the way. That's why I don't mind asking silly questions or being wrong all the time. It's okay with me. So Tesla and Waymo, they became very good by looking at a ton of videos. They train on videos, right? The videos are not language. Okay, they're not language. So without a model of the world, my Tesla drives itself very well, better than me. My Tesla drives it better than when I drive it. I'm nervous when I drive my Tesla, as opposed to Tesla driving on full self-driving mode. So even without a model of the world, even without the linearity of language and the next token prediction, these millions of hours or billions of hours of driving, maybe not billions of hours, but millions of hours of driving, led to the training of a model that works very well. So how can it be?
And when you think about it, when a self-driving Tesla or any other self-driving car, but Tesla are kind of like the topic today. So if a self-driving Tesla is driving so well, it actually needs to make actions all the time. So it needs to have a world model practically, and based on that world model, it needs to make actions in different situations. Like when it actually comes to the specific street, it needs to follow specific rules. It needs to recognize the situation and say, oh, this is the best action to do. This is the correct action. So that's very interesting. those actions would not be possible if the world model would be there. It could not be a simple predictive, because when you think about it, a self-driving Tesla going into the world, it actually goes into an unpredictable world. It doesn't know everything where it's going to go. Like the large language model, anything you ask it, like it has some tokens that it was trained on, and it can predict what is the most likely next word. But a Tesla doesn't know. What if you send Tesla into Amazon forest? Like, would it know what to do? I think it would, probably, because it actually probably created a certain world model on its own. Now, that world model is simpler. That world model is revolving around certain actions that you can do in a car, like you can push the gas, you can do the brakes, you can twist the wheel. So you can maybe have a limited space of actions that you can do in a Tesla car. So it's probably simpler there, but I think it's a very interesting topic, because humans actually find it very difficult to be good drivers. If we think about it, only a small fraction of humans are very good drivers. So Tesla is actually achieving its small fraction of AGI. It can't be called AGI because it's not general, but as you said, it's a very flexible term, and we don't even know what it is. It's like humans. You cannot measure an average human in anything. Like, you cannot measure the average intelligence of a human. We can say, well, this is IQ 100, but all humans are different. Like, there's no way to standardize human intelligence. There are so many types of intelligence. We have such a diversified intelligence. Like, you have the emotional intelligence, the musical intelligence, the social intelligence, the logical intelligence, who knows how many of those that we haven't even defined. So trying to fit an AGI into one box and say, hey, this is AGI, this point is the AGI, I agree, it's very difficult. But I still kind of think that AGI could be used as a good reference point to define what is the artificial intelligence that actually understands the world, at least in a simple way that we do. So we understand the world in a completely different way compared to the LLMs. LLMs just predict things. We don't. We actually think about them. We abstract. We dream about things. We have a lot of things that are unimaginable for LLMs today. So I think that maybe even AMI will be just a step towards that. Maybe a lot of additional work will be needed. But I think that I completely agree. And again, huge respect for Mr. LeCun, and hope that if he watches this show, just want to say that we have very, very positive things to say about AMI and Mr. LeCun.
I really, actually, in closing point, oh, can you hear me?
Okay. Yes, I can hear you.
In closing, I want to repeat what I said, which is that really him and Elon actually have a potential of a deal to do. Too bad they build that sort of social media sort of antagonistic persona, because it'd be quite logical for Tesla and AMI to work together. On that note, Darko, it was a pleasure meeting with you, and thank you for interviewing Yann LeCun from France, who very much appreciated the opportunity as well.
Thank you so much, Bruno, or if I may say, Bruno LeCun. Thank you so much. It was really a pleasure, and au revoir for me.